Hey guys, welcome to this another video, and today we're going to discuss about a particular problem which would be helpful in the number theory section, and we'll be trying to use some formulas and some well-known techniques to use this. So as I've already seen in the thumbnail, the problem is something like this. The fractional part of x plus 1 whole cube is equals to x cube. This is the equation given to me, and this is one of the equations discussed by one of my students to me while I was teaching him, and we need to find the real solutions. Now it's pretty much an objective question, but it's obviously, according to me, should be given as a subjective one because there is a lot of concept involved in it. So I'm just restating the problem. It looks a bit nasty. Let me rewrite it. The problem is fractional part of x plus 1 whole cube is equals to x cube, right? Okay, so now some things about the fractional part. The fractional part of x is such a thing like if you put in a real number, you'll get the fractional part. Some properties are it is less than 1 and greater than 0, but it could be equal to 0, but obviously less than 1. It can never be a whole number, right? So it's pretty much usual. How do we deal with it? But there's some tricks out there because it's x plus 1 whole cube. So first things first, right hand side is something called x cube, but it's not the fractional part. The first thing we need to derive here is the range of x, because if we do not know the range of x, it's almost impossible to solve this equation. So we need to find it out. Now see, the left hand side is a fractional part, which actually says that it has to be less than 1, right? And greater than or equal to 0. So should be the right hand side, which says as 0 less than or equals to x less than 1. Right? Excuse me. Now this thing also guarantees that x cube also lies in the same range, and for that x cube is itself a fraction, a real number which is less than 1 and greater than or equal to 0. That means it itself is a fractional part. So the equation really turns out to be something that fractional part of a number cubed is equals to fractional part of the number added to 1 cubed. So what are those numbers that satisfy these properties? Now how do you find it? Property. This is the periodicity. The periodicity of a fractional part is 1. That means fractional part of n plus 1 will be equals to fractional part of n. Because fractional part deals only with the fractional part. When we are increasing by a whole number or the smallest possible whole number 1, we are just increasing the whole part and we are not affecting the fractional part. So that's why the fractional part of n will remain unchanged if we increase it by 1. Now this property will be used, so we'll first expand x plus 1 whole cube. We get x cube plus 3x into x plus 1 plus 1. Consider this plus 1. This is the periodic property where it applies, and we can safely write that fractional part of x plus 1 whole cube is equals to fractional part of x cube plus 3 into x plus 1, right? Now this should be equal to fractional part of x cube. Now a very important deduction from this phase. X cube is a fractional part. That means it lies between 0 to 1. Right and left hand side is also a fractional part. Now if 3x into x plus 1, this thing, let's assume it's something like this, some I plus f, right? Where f is obviously 0 less than or equals to f less than 1, where I is the integral part. If this is true, then this equation turns into x cube plus I plus f, right? Which should be equal to fractional part of x cube. Now consider one thing, this I is an integer, so it's periodic, and the periodic properties allows us to rule out this x I. which gives us x cube plus f will be equals to x cube. Now consider that since x cube and f are both fractions, now the fractional part of x cube must be same on the right hand side too. So we are adding a fraction here. That means the fractional part will change of x cube itself is a fraction between 0 to 1 fractional part. So this real number is getting added to another real number which is less than 1. Obviously it's going to produce a result which is different, isn't it? Because you cannot have, if f1 and f2 are two different real numbers both less than 1, you cannot have 1 plus f1, right? At least they will at most produce 1 plus the number. So we want f1 back, right? It's same like this, but this cannot happen because if f1 plus f2 is equals to 1 plus f1, then f2 has to be 1, but here both f1 and f2 are fractional parts. It cannot be true. So x cube and f, since both are fractional parts, they can never add to a number whose fractional part will be same as the first one, because that will require we will have to add a whole number to x cube to get that, right? So f must be 0, which proves 3x into x plus 1 must be an integer. Now this is where the problem gets simplified. I'm not going to dig much into the problem, but this is the crucial part. So 3x into x plus 1 has to be some integer n, right? Now first thing, x equals to 0 is an obvious solution, isn't it? Now remember 0 less than equals to x less than 1, that's also a condition, isn't it? Now this is an obvious solution. Now you can just dig about like 3x square plus 3x equals to n. Solve for the quadratic formula. P square minus 4ac by this, which gives you minus half plus minus by 6. Yeah. Now this is what you get. Now obviously there will be certain values of n for which this should be true. Now we need to find such n, right? We need to find such n for which this is true. Obviously if x is not a proper rational number, then this is never going to be an integer. And for x to be rational, 9 plus 12n has to be a perfect square, which gives us 12n equals to k square minus 9 equals to k plus 3 into k minus 3, right? Now a lot of conditions can apply. Let's say first condition, k minus 3 will be equals to 12n and k plus 3 equals to 1. This is absurd, so cancel, because k becomes minus 2. And if k is minus 2, this should be minus 5, n will be minus 5 by 12. Doesn't make sense. But if it's the opposite, k minus 3 is 1 and k plus 3 is 12n, then k is 4, and this becomes something around 7 equals to 12. It still doesn't work. Now we will try k minus 3 is 12, which gives k is 15, and obviously k plus 3 should be n, which gives n as 18. So in this way we can find out all the solutions. 18, I guess 12 also works for n. So these different solutions work, and they will all be counted into solutions because from them you can get the corresponding x, right? So that is the solution of the entire problem. I hope you liked it. So this is the technique of the fractional parts, and it's basically a subjective problem. Okay, so thanks for watching.